If you spend any time online, you have seen the promise. Buy one head of lettuce or a single bunch of celery, stick the base in a glass of tap water, and you will supposedly never have to buy vegetables from the grocery store again. For most people, the reality looks a lot more like this. After a few days of optimism, the water turns cloudy, the base gets slimy and collapsing, and you are left staring at a rotting stump on your kitchen counter. The reason this happens is that these internet hacks routinely ignore basic plant morphology. They trick long-meaning people into treating reproductive plant parts, which have a strict biological life cycle, as if they were vegetative parts capable of infinite cloning. By treating every kitchen scrap the same, you trade your valuable window space, daily maintenance time, and eventual potting soil for yields that are biologically incapable of regenerating into a full harvest. Without understanding the biological limits of the specific scraps you save, garbage gardening quickly devolves into hoarding rotting compost in your kitchen. To figure out which vegetables actually deserve a second chance, we need an objective method of evaluation. We call this the scrap ROI, or return on investment analysis. On the input side of the equation, we have your hidden costs. This includes the minutes you spend changing out water every 2 days so it doesn't mold, the premium sunlight space you allocate in your home, and the sterile potting mix you will eventually need to buy. On the output side, we measure strictly by usable, edible yield. A successful return on investment means producing actual calories or robust flavors you can cook with, not just a few pale, aesthetic leaves. This side-by-side comparison matrix maps out the discrepancy. We weigh the viral hack's promise against the biological reality of the plant and tally up the actual cost in your time and resources to get there. Applying this strict ROI framework clarifies exactly where your time is being wasted, giving you the permission to toss the majority of those scraps into the compost bin completely guilt-free. Let's start by clearing out the most common biological dead ends. Carrots, beets, and turnips are taproots. The edible mass you buy at the store grows exclusively underground to store energy for the plant. When you slice the top off a carrot and put it in a shallow dish, the biological reality is that it will only ever sprout the leafy greens. The orange taproot itself is gone and will never regenerate from that scrap. Next are biennials, like romaine lettuce and celery. These plants are structured to push new growth entirely from their center core. The outer stalks you cut away will not grow back. Because the plant is already at the end of its life cycle, that center core will quickly bolt or try to go to seed. When that happens, the structural integrity weakens and the leaves become notoriously tough and bitter. Because they demand daily water changes and soil, yet yield almost 0 calories, carrot tops, celery bases, and romaine hearts drop into the high-input, low-yield quadrant. They sit in this red zone because you expend weeks of maintenance for a handful of bitter leaves. Unless your strict goal is to grow a temporary houseplant or allow the carrot to flower to attract pollinators to your yard, regrowing taproots and biennials is a massive negative return on your investment. To actually lower your grocery bill, you need vegetative propagators. These are plants equipped with specific nodes or eyes that essentially clone themselves, producing exact replicas of the parts you want to eat. The potato offers a massive return. If you take a single sprouted scrap from your pantry, cut it so it has one eye, and plant it in dirt, it will multiply into 5 to 8 brand new, full-sized potatoes. Herbs like basil and alliums like green onions follow a similar cloning process. Placing a cut basil stem or the white bulb of a scallion in water encourages rapid root development, followed by a continuous, exponential growth of identical edible leaves. Updating our quadrant chart with these crops shows a totally different picture. Green onions and basil shoot into the low-input, high-yield zone, while potatoes land in the medium-input, extreme-yield quadrant. If your primary goal is practical grocery savings, vegetative propagators are the only scraps that actively earn their keep on your counter space. But even with the right crops, the water glass method is a trap. Tap water contains 0 nutrients. Leaving a successfully sprouted scrap permanently in water will eventually dilute its flavor, stunt its growth, and starve it. A plant reacts to its environment. Water roots grow to be long, thin, and highly fragile because they don't have to work hard to absorb moisture. Soil roots, however, grow thick and strong to fight their way through dirt and extract complex nutrients. Plants left purely in water remain physically vulnerable, with delicate root systems snapping under the slightest pressure, leaving the plant unable to support robust growth. To prevent transplant shock and nutrient starvation, you must transfer your water-propagated cuttings into sterile potting mix the moment those water roots hit 1 to 2 inches in length. True, long-term ROI requires the nutrients only dirt can provide. A glass of water is a temporary incubator. It is not a permanent home. Ginger serves as the perfect case study for how transitioning to soil dictates your success. It is a top-tier vegetative crop, but you will only see a return if you move it out of the kitchen and into the dirt. The early germination phase requires spreading chunks of the rhizome in shallow trays filled with moist growing medium. At 70 degrees, it takes weeks to coax out these initial isolated green sprouts. Once sprouted and moved outdoors to a larger container, the ginger requires a process called hilling. You progressively mound several inches of soil over the base of the plant as it grows through the summer, forcing the rhizome to expand. Provided with proper space, fertilizing, and deep soil, the yield reaches a massive scale, producing thick, towering leafy growth and heavy clusters of ginger underground. Investing the effort to move a scrap out of a shallow dish and into deep, nutrient-rich soil is the exact mechanism that separates an internet hack from a sustainable harvest. The final step to succeeding with kitchen scraps is aligning the biological reality of these plants directly with your lifestyle goals. The Scrap Garden Blueprint decision tree splits into 2 profiles. The practical optimizer propagates high ROI crops like green onions, basil, and potatoes, transitioning to soil, composting the rest. The curious experimenter sprouts avocado pits and flowers carrot tops for aesthetic joy, not a free salad. True sustainability is not hoarding rotting lettuce in a windowsill glass. It is efficiently growing the exact crops that match your goals and trusting the compost pile to handle the rest.